Is it recording? It's recording. Okay. Hello, this is Mr. Harris. I'm working through problems 28 and 31. I'm going to share the screen. Um, um, I'm going to start off with 31 since, no, I'm going to start off with 28 for the heck of it. I'll do 28 and then I'll do 31. I'll be posting this to YouTube video. Take a screenshot if you need. When I go back to working through, I don't know if the video will record this or not. It's up to you. So here's 28 and 31. If this is for the student that requested the specific questions, will you have them in front of you? So I'm going to work 28 regarding the parlor guitar. Okay, here's my notes. These are ratio proportion problems. So they're telling us in a certain music store, every guitar is either a dreadnought or a parlor guitar. Okay. So it's either a dreadnought or a parlor guitar. The ratio of dreadnoughts to parlor guitars in a music store is 4 to 15. And we can also write that in terms of a ratio 4 to 15. And there is a total of 115 guitars. 114 guitars in the music store. How many guitars in the music store are dreadnoughts? Okay, so when we're talking about these proportions, the genesis of these proportions is you had an actual amount and then you simplified it. For example, if let's say we had 100 to 25, and we also wrote it as 100 to 25. 100 to 25 is the same thing as 4 to 1 or 4 to 1. What that really means is we multiply 4 times 25 and 1 times 25. So you can view these ratios as 4x to 1x. This x has to be the same number because you want to think about, well, what number do they have in common? So if I multiply this by 25, that by 25, I will get 100 over 25. If in case my x was equal to 5, it would be 20 to 4 ratio. Writing it like 24x, meaning in this case my x equals 5, in this case my x equals 25. That's one way, that's how we can view these to make sense. I'm gonna get a fresh piece of paper because I already wrote all over that one. So back to the dreadnoughts and parlor guitars. I have to look up what a dreadnought or parlor guitar is. Whatever that is. I know they're guitars, but I don't know, such interesting names. Dreadnoughts for parlor guitars 15, 4 to 15 ratio. They tell us there's a total of 114 guitars in the entire music store. So how many guitars in a music store are dreadnoughts? Using what we discussed previously about that sort of hidden factor, hidden multiple, I'm going to set this up where, yes, we have a 4 to 15 ratio, but I can also write it as 4x to 15x. And we want to figure out what that x is. In this case, if we had 100 to 25 with the original numbers, in total we would have 125, so we would literally add them. In this case, we can't simply literally add them. We have to add 4x plus 15x to 114 because this is some sort of fraction broken down. So we do 4x plus 15x equals 114 guitars. And then we solve for x. We're going to get that common multiple. And then once we get the common multiple, we can figure out how many dreadnoughts there were specifically. So I'm going to do, I get 19x equals 114. 114 divided by 19 is 6. So I have x is equal to 6. Therefore, 6 times 4 is 24. 6 times 15 is 90. So originally it was 24 to 90, but they simplified it to 4 and 15. Dreadnoughts to parlor guitars. So that means there's 24 dreadnoughts. How many guitars in a music star are dreadnoughts? So again, dreadnoughts to parlors equals 4 to 15. In this case, equals 24 to 90. So there's 24 dreadnoughts and 90 parlors. 90 plus 24 is 114. And this was number 28. Off to do number 31. Share the screen again. Okay. Jars contain red, white, and yellow candies. Then you subtracted 7. You subtracted 5. And you added 3 pieces of yellow candy are added, leaving with a ratio of 4 to 2 to 3. The jar contains only those 3 colors. It's nice we don't have any other factors to consider. How many pieces were originally in the jar? Okay, let me flip this over and do a fresh sheet. I'm just looking for my original notes so I don't have to. But you know, I'm just gonna rewrite these because I'm looking for. It's always good to simply pull out all the information in a little container. So here we have red, white, and yellow candies, red, white, yellow candies, and a 9 to 5 to 4 ratio. 7 pieces of red candy minus 7, and 5 pieces of white candy removed minus 5 plus 3. It leaves us with a 4 for red to 2 for white to 3 yellow. Okay. Now that that's set up, let's sit and think about what's a reasonable approach to this. Yeah, 9, 3, 4, multiple of 3. Okay, so what I'm going to do is just to make my life easier, I will just focus on 2 of these at a time because I can figure out that hidden multiple by the relationship between 2 of these because it's all the same multiple, meaning we can write this as 9x, 5x, 4x. So looking at this hidden multiple, I'm just going to focus on the reds and the whites. I'm going to focus on the 9x and the 5x situation. And I'm going to set this up where it's red to whites equals 9 to 5 equals the new ratio 4 to 2. So again, red to white ratio 9 to 5 now equals 4 to 2. So we want to figure out what can we do to turn the 9 to 5 ratio into a 4 to 2 ratio. With that, we subtracted 7 and 5. So before I do that, let's remember from number 28 or whatever number that was, we can also rewrite this as 9x over 5x. And beyond simply having this common factor that was originally simplified from, we also have 9x minus 7 because we took 7 from the reds. And beneath that, we have 5x minus 5 because we took 5 from the whites. So whatever this x is, after removing 7, we're left with the ratio of 4 to, after removing 5, a ratio of 4 to 2. You can see right here, we have a nice little equation. We can cross multiply and do all that stuff we need to. So again, we set up these ratios. Instead of doing 3, I'm going to just focus on 2. 9 to 5, 4 to 2, 9x minus 7 to 4, 5x minus 5 to 2. So now I'm simply going to multiply. Let's do, make sure I have enough space. 2 times 9x minus 7 equals 4 times 5x minus 5. That gives me 18x minus 14. equals 20x minus 20. Negative 14 equals 2x minus 20. 6 equals 2x. 3 equals x. So it's a multiple of 3, which means either it's going to be times 3 or by some multiple of 3. In this case, it works out where it's just times 3. So now that we know that that hidden x, that hidden multiple is 3, I can actually go back to all my original values where we had 954, except now we know it's 9 times 3 to 5 times 3 to 4 times 3. 9 times 3 is 27. 5 times 3 is 15. 4 times 3 is 12. So we actually have the actual original amount. We had 27 reds, 15 whites, and 12 yellows. Now let's see what happens when I subtract 7 from the reds, I get 20. When I subtract 5 from the whites, I get 10. And when I add 3 to the yellows, I get 15. Now let's think about this particular ratio. 20, 10, 5. We know that the common factor is 3. So there's some relationship behind a common ratio and a common factor of 3. Another thing we can think about is we can outright compare this to what we were given, 4 to 2 to 3. And let's think about how we would even go about this. It turns out that the common ratio 3 changed in simply subtracting 7, subtracting 5, adding 3, but we have a new common ratio. I'm looking at 5. 5 times 4 is 20. 5 times 2 is 10. 5 times 3 is 15. So in this case, we end up having to change that common ratio. And what's really going on is we're simply simplifying by a common term. So we can write this as 4 times 5 to 2 times 5 to 3 times 5, because we know 3 times 5 is 15, 2 times 5 is 10. Or we could just write it as 4x to 2x to 3x. And mathematicians, like normal, they like cutting corners. They like simplifying as much. That's how we're left with a 4 to 2 to 3 ratio. So it pans out either way. We're left with this original value where we get 25, 15, 12. Subtract 7, subtract 5, add 3. We're left with this new value. 20, 10, 15 happens to be able to be easily simplified into the given ratio they told us. 20 divided by 5 is 4. 10 divided by 5 is 2. 15 divided by 5 is 3. So let's reread. If the jar is only 3 colors of candy, how many pieces were originally in the jar? Again, there you go, SAT questions. We didn't even really need to go this route to verify that it was 4, 2, 3. They really only asked us to get 9 times 3 plus 5 times 3 plus 4 times 3. But remember, you couldn't simply add 9, 5, and 3. You had to figure out what that common multiple was. So when I add that, just to avoid careless mistakes, 27 plus 15 plus 12, I got 54. So going through again, red, white, yellow, we got the ratio, subtracted the new ratio. I just pulled the red and the white to compare, remembering that there is a common multiple that was originally simplified. Red and white is 9 to 5. That 9 to 5 became 4 to 2. In order to become that 4 to 2, we know 9x, 5x. So that's where I get 9x minus 7, 5x minus 5, set equal to 4 to the 2 ratio. Solve for x, I get that that common multiple is 3. Essentially, what do I have to do to this to go down there? Now that I know the common multiple is 3, I do 9 times 3, 5 times 3, 4 times 3. I add them all up. I get 54. That's my total amount of whatever these are. What are these, candies? Candy pieces. That's my answer, 54. Just for the sake of exploration, if you wanted to go further and figure out, well, how does the ratio work out going forward? You have to change your m because it's slightly different, but it still works out. It changes it where it's in a slightly different ratio. And this is number 31. I'll share the screen again if you don't already have 31. Hooray, hooray, hooray. It's all 37, I'm close. Stop recording. Thank you very much. Have a good day.